how much? M square minus A square is equal to 0. Okay, implies M square must be equal to A square, implies M is equal to plus or minus A. Okay, so therefore, what will be the solution? Complementary solution. Here the letter is Z, dependent variable is Z. So Z is equal to C1 e power ax plus C2 e power minus ax. Fine. So implies we are using here partial differential equation. Instead of C1 and C2, we need to replace with C1 equal to f of y. Similarly, C2 is equal to g of y. Clear? Because opposite variable you have to take. That means other variable you have to take. Okay. So arbitrary function is f of y and g of y. So replace it now. So the solution is z is equal to f of y plus e power ax plus g of y e power minus ax. Fine. So now we need to find g of y and f of y using the given conditions. So let us see the first condition, condition 1. So what is the condition 1? Take x equal to 0 when dou z by dou x is equal to a sin y. Okay, dou z by dou x we need to find from equation 1. So take this as equation 1. So implies from equation 1, okay, dou z by dou x will be how much? F of y is a function of y, so it is constant. Differentiation of e power ax. How much? Differentiation of e power x with respect to x.
A into e power x.
A into e power x. Yes. Plus g of y. Differentiation of e power minus ax.
Minus a into e power minus a.
Minus a into e power ax. Correct. So implies dou z
Minus
by
e power minus
dou
x, no, sir.
x is equal to
Sir, e power minus ax, no, sir.
minus.
E power minus
Yes, yes.
ax.
Yeah. So a into f of y e power ax minus g of y e power minus ax. So we got this expression like this, but dou z by dou x at x equal to 0 we need to find. So its value is a sin y. So find this value at x equal to 0. What happens? Left hand side a sin y will get is equal to substitute x equal to 0 here. How much will get? F of y e power a into 0. So I'll get 1 e power 0 1 minus g of y into e power minus 0. So it is 1 again. So take it as equation 2. Okay. Next, take the condition 2. Okay. So dou z by dou y equal to 0 when x equal to 0. Okay. So from equation 1, okay, what will be dou z by dou y? So observe this equation 1, f of y, differentiation of f of y. It is f dash of y e power ax plus g dash of y e power minus ax. Okay, so implies dou z by dou x dou y at x equal to 0 is equal to f dash of y e power ax plus g dash of y e power minus ax at x equal to 0 we need to find. So left hand side 0 we have to put, since they have given 0 is equal to, substitute x equal to 0 on the right hand side, f dash of y plus g dash of y. Okay, now from this equation if you observe the previous condition, so we got equation 2 in terms of f of y and g of y. So if I want to convert this, what I need to do? We need to apply integration on both sides to
Integrate.
remove derivatives. Yes, integrate with respect to y. Okay, if you integrate with respect to y, what happens? Here also functions are in terms of y only. So here I am taking integrating constant in the left hand side, that is k is equal to f of y plus g of y. Okay, take it as equation 3. Okay, so now suppose if you take equation 3 plus 2, okay, what happens? K plus sin y is equal to f of, sorry, 2 into f of y. Okay, implies f of y is equal to how much? K plus sin y divided by 2. Okay, so take it as equation 4. Similarly, if I take equation 3 minus equation 2, you'll get k minus sin y is equal to 2 into g of y. So implies g of y is equal to k minus sin y divided by 2. Take it as equation 5. Okay, now substitute equation 4 and 5 in equation 1. Okay, so that f of y and g of y will be eliminated. So therefore substitute equation 4 and 5 in 1. So what happens? I'll write it in next slide. Z is equal to k plus sin y divided by 2 into e power ax plus k minus sin y divided by 2 e power minus ax. So implies z equal to, suppose if I take k common, what happens in both the terms? E power ax plus e power minus ax divided by 2. Similarly, plus sin y if I take common, e power x minus e power minus ax divided by 2. Fine. So z is equal to how much? K into
cos h of ax.
what is this actually? Cos
Cos
h
h of
ax. Sin y into this value is sin h ax. So this is the final solution which is required. Lagrange multipliers, methods of multipliers. Lagrange method of multipliers. Okay. So let us have a standard form which is of the form capital P of small p plus capital Q of small q is equal to R, where P comma Q comma R, sorry, P comma capital Q comma R are functions of x, y, z. Okay, these are functions of x, y, z. And small p and small q, these are dou z by dou x, dou z by dou y. Okay, whenever your partial differential equation of this form, that means this is called linear partial differential equation. So then your auxiliary equation will be of like this: dx by p is equal to dy by q, that means this is capital Q, and dz by r. Okay, so this is the auxiliary equation. Okay, from here we can solve in many methods. Okay, one of the method is comparing two pairs at a time. Okay, we'll get two solutions and the final solution will be written as function of c1 comma c2 we used to write. This already we have studied in the previous semester while applying Lagrange method for solving this vector integration. Okay, we have done this, and along with that we can apply ratios and proportions also. Okay, if you see here, ratio and proportions, whenever you are having three ratios of a1 by b1, a2 by b2, a3 by b3, this can be written as also k1 a1 plus k2 a2 plus k3 a3 divided by k1 b1, k2 b2, k3 b3. Okay, so what are these k1, k2, k3? These are the multipliers. We call it as multipliers. Now our job is how to find these multipliers. Okay, so after finding the multipliers, just we have to write the function u of x comma y comma z equal to c1, v of x comma y comma z equal to c2, and final answer will be of this form: f of c1 comma c2 or phi of c1 comma c2. Okay, so let us see the problem so that you'll get an idea. So here he asked us to solve p cot x plus q cot y is equal to cot z. Okay, so here capital P of x comma y comma z is nothing but cot x. Capital Q is nothing but cot y. And capital R is nothing but cot z. Okay, so implies small p is equal to dou z by dou x, and small q is nothing but dou z by dou y. Okay, so now what we need to do is, let us see. Okay, so dx divided by p, what is p? Cot x, is equal to dy divided by cot y. Similarly, dz divided by r, that is cot z. Take it as equation 1. Okay, now consider first two pairs. Consider dx by cot x is equal to dy by cot y. Implies, what is meant by 1 by cot? 1 by cot is nothing but tan x dx is equal to tan y dy. Implies apply integration on both sides. So what happens if you apply integration on both sides? Integral tan x dx is equal to integral tan y dy. Implies, what is integration of tan x? Integration of tan x,
log
Log sec x.
sec x plus
log secant x is equal to log secant y plus all terms are is in terms of log, so I can write the function as log of some c1. Since it is ordinary derivative only, so we have written in terms of c1. Implies log secant x minus log secant y is equal to log c1. So implies log of secant x divided by secant y is equal to log c1. Implies, what happens? Secant x divided by secant y is equal to c1, you can write. Okay, so take this as equation 1. This is one of the solution. Similarly, consider dy by cot y is equal to dz by cot z. Implies the solution is proceed like similar way. Okay, so what happens? Secant y divided by secant z is equal to c2 will get. Okay, so implies the solution of given PDE is phi of C1 comma C2 equal to 0, which is nothing but phi of C1 is nothing but secant x divided by secant y comma secant y divided by secant z equal to 0. This is the required solution. So here given this problem, so here capital P is equal to y minus z and capital Q is equal to z minus x and capital R equal to x minus y. Okay, implies, sorry, similarly small p equal to dou z by dou x and small q equal to dou z by dou y. Now the auxiliary equation is p divided by y minus z, similarly q divided by z minus x, sorry, it is not p, it is dx, this is dy, this is dz divided by x minus y. Okay. Now, if you do anything, take this 2. Okay. Is it possible to solve if you do cross multiplication? Will it be integrable easily? No, right? Because one more letter z is involved. We cannot integrate again. Okay. So for that sake, what we need to do, we have to go for Lagrange multipliers. Okay. So Lagrange multipliers, how to find we need means we have to take denominators, all the denominators, y minus z. Here z minus x. Okay. Next x minus y. Put all plus here, middle. Okay. Now you have to fill k1, k2 and k3 such that this sum should be 0. Okay. You have to select k1, k2, k3 values such that this sum must be 0. Is there any possible way? You can take numbers or you can take letters, anything. Suppose if I take k1 equal to 1, k2 equal to 1 and k3 equal to 1. All ones I have taken. So I'll get y minus z plus z minus x plus x minus y. Okay. If you substitute k1 equal to 1, k2 equal to 1 and k3 equal to 1, all letters will get cancelled. You're getting 0. So that is what we want. So this is one multiplier. Okay. Similarly, I have to take k1 dash, k2 dash and k3 dash. Okay, we'll get for every problem we'll get to 2 multipliers. Okay, one of them we have found. What is one more? Suppose if I multiply with first term with x, second term with y and third term with z, what happens? X into y minus z plus y into z minus x plus z into x minus y will be how much? We'll check. How much? Xy minus xz plus yz minus xy plus zx minus zy. Okay. So plus xy minus xy plus yz minus zy zx xz. Okay. All get cancelled. We got 0. Okay. So for this problem we got 2 multipliers. So these and all you have to do it in rough. Okay, these and all you have to do it in rough. Okay, once you find k1, k2, k3, k1 dash, k2 dash and k3 dash, now we have to take this as equation 1 by ratio and proportion property. What we'll do is dx divided by k1, dx into k1 and denominator into k1. So that means 1 into dx divided by all, sum of all these we will take. Okay, plus 1 into dy plus 1 into dz divided by 1 into y minus z plus 1 into z minus x plus 1 into x minus y. Okay, in denominator we'll get 0 obviously. Okay, so I'll write it down. And this must be equal to some constant because all these ratios will be equal to some C1, right? Some constant C. Take it as equation 1. Equate it to C only because all these ratios will be same. Okay, I have equated to C. Dx plus dy plus dz divided by 0 will get equal to c. Now dx plus dy plus dz must be equal to 0, implies integrate on both sides. Integral dx plus integral dy plus integral dz equal to 0. Now x plus y plus z, because integral dx is x, integral dy is y, plus integral dz is z, is equal to some integrating constant. I can take it as c1. Okay, so this is one of the solution. Next, second multiplier. What is that second multiplier? K1 dash equal to x, K2 dash is equal to y, and K3 dash is equal to z. Okay, again by applying ratio and proportion, on equation 1. What is K1 here? X. So x into dx you write, plus y into dy you write, plus z into dz divided by same x into y minus z plus y into z minus x plus z into x minus y must be equal to some constant c. So x dx plus y dy plus z dz divided by 0 equal to c will get x dx plus y dy plus z dz is equal to c. Fine. Now integrate on both sides. We'll get integral x dx, integral y dy, integral z dz is equal to 0. So implies what will be the solution? X square plus y square plus z square equal to some c2. So take it as equation 2, take it as equation 3. So therefore the required solution is okay, phi of c1 comma c2, that is nothing but equal to 0, phi of x plus y plus z comma x square plus y square plus z square is equal to 0. So this is the required solution. So observe this problem, this is also same. So the equation of the form capital P into small p plus capital Q into small q is equal to capital R, where here small capital P is equal to x into y square minus x square. Sorry, this is not y square minus x square, it is y square minus z square. Okay, capital Q is equal to y into z square minus x square. Next, capital R equal to z into x square minus y square, implies what happens? So we'll write dx divided by, or you can write auxiliary equation is dx divided by x into y square minus z square is equal to dy divided by y into z square minus x square dz divided by z into x square minus y square. Now we have to consider all the denominators and add it. X of y square minus z square plus y into z square minus x square, next plus z into x square minus y square. Okay, so which we should make it as 0 by using some multipliers here. So that will be k1, k2 and k3. Okay, so can anyone tell which term or which variable if you multiply will become 0? You can select numbers or letters.
K1 equal to X, K2 equal to Y, K3 equal to Z.
X, Y and Z. Okay, let us see. X, if you multiply, you'll get x square into y square minus z square. So I can write it as x square minus x square z square. Y square z square minus y square x square. Z square minus, sorry, z square x square minus z square y square. So zy here yz, xy, yx, yes, xz. So we are getting 0. So this is 1. So k1 equal to x, k2 equal to y, and k3 is equal to z. This is one function. Similarly, find one more. Now I need to find k1 dash, k2 dash, and k3 dash. Suppose if I able to cancel these letters, what happens? Y square, my y minus z is there, z minus x is there, x minus y is there. Automatically it will get cancelled. So what might be multipliers?
1 by
1 by X,
Yes.
1 by Y, 1 by Z.
1 by x, 1 by y, and 1 by z. These are all multipliers for us. Okay. Using the multipliers, k1, or you can write it as x comma y comma z, and apply ratio and proportion in equation 1, will get, take it as equation 1, implies what we need to do, multiply these multipliers to numerators and add it, and the same multiply to denominators and add it. So x dx plus y dy plus z dz divided by x square into z square minus, sorry, y square minus z square plus y square into z square minus x square. Similarly, plus z square into x square minus y square equal to, you can take it as some c, because this will be equal to some constant c. So this automatically it will become 0. We have verified it. So x dx plus y dy plus z dz must be equal to 0. Now apply integration, integral x dx, integral y dy plus integral z dz equal to 0. Implies x square by 2 plus y square by 2 plus z square divided by 2 equal to some c1 I can write. Or we can take this denominator to right hand side, x square plus y square plus z square equal to c1. In the left hand side, sorry, here you can write it as c1 dash. So that I can write 2c1 as c1. c1 dash into 2, yes, c1. So this is one function. Similarly, by using multipliers 1 by x, comma 1 by y, comma 1 by z in equation 1 and apply ratio and proportion. What happens? 1 by x dx plus 1 by y dy plus 1 by z dz divided by y square minus z square plus z square minus x square plus x square minus y square equal to some c. So all get cancelled. Finally, 1 by x dx plus 1 by y dy plus 1 by z dz equal to 0. Now we apply integration, integral 1 by x dx 1 by y dy plus 1 by z dz equal to 0. Okay. So finally, log x plus log y plus log z is equal to log c2. So this can also be written as log of x into y into z is equal to log c2. Implies x y z is equal to c2. Take it as equation 1, take it as equation 2. Therefore, the required solution is how much? Phi of c1 comma c2 equal to 0. That is nothing but phi of
x square plus y square plus z square.
x square plus y square plus z square comma x y z equal to 0. So this will be the required solution. Check with this. Here they asked us to solve mz minus ny into dou z by dou x plus nx minus lz into dou z by dou y equal to ly minus mx. So let us see. So it is of the form capital P into small p plus capital R into small r, sorry, capital Q into small q is equal to capital R. Okay, so where here P is nothing but mz minus ny. Next q is nothing but nx minus lz. Okay. Next r equal to ly minus mx. Okay. So now when it is of this form, what will be the auxiliary equation? Auxiliary equation is how much? Dx divided by mz minus ny is equal to dy divided by nx minus lz is equal to next r divided by what is r? Dz divided by ly minus mx. Okay, so this is like auxiliary equation. That means dx by p is equal to dy by q is equal to dz by r. Okay, so now what I'll do is first I have to find what are the Lagrange multipliers for this. Okay, so for that sake what I have to do, first take the denominators mz minus ny, okay, plus here nx minus lz plus here ly minus mx is equal to 0 we have to prove. That means some k1, k2, k3 values we have to select in such a way that this whole should become 0. Okay, so is there any possibility will this sum will be 0? Yes,
No, sir.
check with the any letters. If you substitute k1, k2, k3, this sum should be 0. Suppose if I take k1 equal to L, k2 equal to M, k3 equal to N, what happens? Let us check. L into mz minus ny plus m into nx minus lz plus uh, n into ly minus mx. So you may get a doubt why you got this. It is of the form z minus y, x minus z, y minus x. So here if you take a z term will be having opposite symbols, y term is having opposite symbols, x term is having opposite symbols. Suppose if I multiply with other letters, it will get 0. Okay, that is a strategy. So are you getting 0 now? You'll get lm here, lmz minus lmz lny, mnx minus lmz plus nly minus nmx. So here this will get cancelled. mnx mnx lny lny. So you are getting 0. Okay, so these and all things you have to do it in rough. Okay, just for your reference I am writing here. You are getting 0. So this is one Lagrange multiplier. Okay, Similarly, I have to select again k1 dash, k2 dash and k3 dash. Suppose if I take instead of lmn, if I take x, k2 dash is y, k3 dash is z. Okay, what happens? Just observe. X into first term, it means mz minus ny, okay, plus y into nx minus lz plus z into ly minus mx is equal to 0. Okay, sorry, 0 we have to prove. Okay, so let us check once. What happens? M into zx minus n into xy plus n into xy minus lyz plus lzy minus mzx. So zx get cancelled, nxy nxy, lyz lyz. So we are getting 0. Okay, so we got two multipliers. We can make use of these two multipliers now. Okay, so now these are all rough up to these lines. Okay, now here onwards I am going to continue using the multipliers. Take it as equation 1 using the multipliers. First one multiplier I will take m l m n. I will take l m n and applying ratio and proportion. Ratio and proportion. Okay, so we'll get what we'll get, all these multipliers you have to multiply with all the numerators and add all the numerators. Okay, so that means l dx plus m dy plus n dz divided by uh, mz minus ny into L plus nx minus lz into m plus ly minus mx into n. Okay, this equal to some constant you have to take, because all these ratios will be equal to some constant, that is c. I am taking here, also you take c. Okay, in denominator obviously you will get 0 because we have tested here. Okay, so for that sake l dx plus m dy plus n dz divided by 0 will get equal to c. If you send this 0 to right hand side, so that will be 0. So l dx plus n dy plus n dz is equal to 0, implies apply integration on both sides. Integral l dx plus integral n dy plus integral, sorry, m dy n dz is equal to 0, implies, so lx plus my plus nz is equal to some integrating constant you have to put. You can put it as c1 or you can put it as u also, whatever the letter you want other than xyz lmn. Okay, so this is a function of xyz, so take it as equation 2. Similarly, using the multipliers, x comma y comma z on equation 1 and applying ratio and proportion okay, so we'll get it as multiply xyz to all the numerators and add it. Similarly, multiply all xyz to denominators and add it. So x dx plus y dy plus z dz divided by here mz minus ny into x into mz minus ny plus y into nx minus lz nx minus lz plus z into ly minus mx. This will be equal to some c, okay, some constant. Now if you add all this, you'll get 0 in the denominator. So numerator will be x dx plus y dy plus z dz is equal to, if you send this 0 to right hand side, you get 0. Now apply integration, integral x dx plus y dy plus integral z dz equal to 0. Implies what happens? X square plus y square plus z square is equal to 0 will get. Fine. Sorry, is equal to some constant. I can take this as v, and I am taking this equation as equation 3. Okay, because integration will be what? You may get a doubt, sir. It is integration is x square by 2, right? So I can write this as x square by 2, y square by 2, z square by 2 is equal to some constant you can take, that is some c1 you can take. If you take all this at a time, x square plus y square plus z square is equal to 2c1. So this 2c1 I can take it as v. X square plus y square plus z square is equal to some v I'll take, since v is equal to 2c1. Okay. Okay. Now we got equation 3. So therefore the required solution is function of equation 2 and 3. So that means phi of u comma v, which is nothing but phi of lx plus my plus nz comma x square plus y square plus z square. Fine. So this is the required function which we require. Okay, this is a different kind of problem. Okay, you just check once. Here it is also of the form capital P into P, capital Q into small q is equal to capital R, where capital P is nothing but y plus z, capital Q is nothing but z plus x, capital R is nothing but x plus y. Okay, so implies auxiliary equation is what happens? Dx divided by y plus z is equal to dy divided by z plus x plus r, sorry, r is nothing but equal to dz divided by some x plus y is equal to some c. I'm taking it as some equation 1. Okay, this all ratio will be equal to some constant, that is c. I'm taking this equation as equation 1. Okay, so now what I'll do is take any number or anything. Okay, whether you are getting 0 or not, we have to check it once. Okay, you are getting any multipliers such that their sum is 0. You take any multiplier, you can take numbers also even.
0, sir.
Huh?
If you
Other
take
than 0.
multiply, sir, 0, 0, 0.
No, you can't take all zeros. It is obviously 0, right? Other than 0, you have to select. Suppose if it is 1, it is minus 1, and suppose it is again minus 1. What happens? Y plus z minus z get cancelled. Okay. Yes. Is it possible? Y plus z
Minus 2x will remain, sir.
minus z minus x minus y. But here minus 2x you are getting. Okay. So this is not possible. Y get cancelled, z get cancelled, x will remain. So we don't have any multipliers which contains which becomes 0, where the sum is 0. So at the time what I will do is, we have one more property in ratio and proportions. Okay, suppose this sum can also be written as sum of all numerators. Okay, take all the sum of numerators. What happens? Dx plus dy plus dz divided by, take sum of all these. What happens? You'll get 2x plus 2y plus 2z. Okay, this ratio also will be same. Is it fine? Sum of all the numerators divided by sum of all the denominators. Okay, next. If you want, we can check if all the ratios will be same. Suppose, for example, uh, 4 by 2 is there. What is the result? 2, right? So make other two fractions which gives the result as 2. You can select other fractions such that you will get the same result.
2 by 4.
Hmm? Suppose you can take 12 by 6. Suppose if I take uh,
8 by 4.
uh, 8 by
8 by
4.
4.
Okay, 8 by 4 I have taken. These will give the same result, right? Equation ratio as 2 to 2. Okay, you can check. 8 plus 4, 8 plus 4, it is 12. So 24 divided by, this is how much? Sum 10 or 12.
12.
You are getting ratio as 2, right?
Yes, sir.
So you can apply this property. It will be work out for every kind of situation. Okay. So this property also we can use. We have to sum all the numerators divided by sum of all denominators. Okay. So this property I have applied here. If you are not getting here, I can split it and write. Here what I did is y plus z plus x plus y. Okay. So this also can be done. Next, suppose if I take these two terms, I'll subtract one on the another. Okay. Suppose if I take dx minus dy, denominator also you have to subtract. What happens? Y plus z minus z minus x. This ratio will be also be same. Suppose if you want, you can take this also. 4 by 2 is equal to 12 by 6, right? Suppose if I subtract numerators and denominators, what happens? 12 minus 4 divided by 6 minus 2. So this is nothing but 8 divided by 4. So this result also will give the same ratio as 2. Correct. So in the same way, we can do this also. Addition and subtraction also. Okay. Similarly, I am taking first and last. This term and this term I am taking. What happens? So this first and last you take. Dx minus dz divided by yes y plus
Y
z
plus Z minus X minus Y.
x minus y. Okay, so just simplify this. How much will get? Dx plus dy plus dz divided by 2 into x plus y plus z is equal to what happens?
Dx minus dy divided by Y minus X.
Z get cancelled, y minus x. Okay, is equal to next dx
Dx
minus
minus
dz
dz divided by Z minus X.
z minus x. Okay, so now yes, so now instead of taking equation 1, I will take this as equation 2. Now consider two terms at a time. Consider dx plus dy plus dz divided by 2 into x plus y plus z. Okay, so this is equal to dx minus dy divided by y minus x. Okay, you can write this as minus of x minus y also. Correct. Why I am taking this one means here, suppose if you are taking dx plus dy plus dz, this value can also be equal to d of x plus y plus z. Can I? Why? Because if you do integration on both sides, what happens? It gives the result as x plus y plus z. Clear? So for that sake, I can write dx plus dy plus dz as d of x plus y plus z. Okay, so that your integration will be easy. So for that sake, I can write this as d of x plus y plus z divided by 2 into x plus y plus z. Similarly, here also in the same way, I can write d of x minus y divided by minus of x minus y. Now, if you do the integration on both sides, what happens? It is of the form integral 1 by 2x dx. So, what is the result? 1 by 2 into integration of 1 by x. Integration of 1 by x.
Log X.
Log x.
Log
So,
X.
yes. The result here is also log of 1 by 2 log of x plus y plus z will get. Similarly, here also what happens? Minus log of x minus y will get. Okay. Plus some integrating constant log of u I can take, or log of some c1 you can take. Okay. So what happens if you take it to left hand side? Log of this can be written as root of x plus y plus z. If I take numerator 1 by 2 to power m log a, I have taken as log a power m plus log of x minus y is equal to log c1. I can write this as log of root x plus y plus z divided by x minus y is equal to log.
Sir, into x minus minus, sir.
Huh?
Plus,
Oh, sorry,
it is plus
into.
no, sir.
Yes, yes, into. In the middle, into is there. Sorry, plus is there means into. Log m into n. So that means x. 1 minute. X minus y into root of x plus y plus z is equal to log c1. So log get cancelled. X minus y into root of x plus y plus z is equal to c1. Okay, or we can take it as uv also, no problem. So take this as equation 3. Okay, so after getting this, I have to find one more solution by equating other two terms. Correct. So I will equate other two terms. Okay. So this time I will equate these terms. Dx minus dy divided by y minus x is equal to, next here also, dx minus dz divided by z minus x. Okay, so now what I will do is I can write this as d of x minus y divided by, here I have to write minus of y, sorry, x minus y is equal to d of x minus z divided by minus of x minus z, you can write. So this minus and this minus get cancelled. Apply integration. So integral d of x minus y divided by x minus y is equal to integral d of x minus y, sorry, d of x minus z divided by x minus z. So integration on both sides, if you do, what happens? Integration of 1 by x. This is log x. So log of x minus y is equal to log of x minus z plus log c2. Okay, so log of x minus y minus log of x minus z is equal to log c2. We can write it as log of x minus y divided by x minus z is equal to log c2. So log get cancelled. X minus y divided by x minus z is equal to c2. So you can take this as equation 4. So therefore the required solution is what happens? Phi of c1 comma c2, which is nothing but phi of x minus y into root of x plus y plus z comma x minus y divided by x minus z. Okay, so this is the actual solution.